So today, we're here to talk about implementing DORA, and we're going to use a new and growing open source tool, Apache DevLake. A quick introduction to myself. So my name is Hezheng. I actually started my journey that brings me here today as a PhD candidate at UC Berkeley, where I was studying algorithms and methodologies to assess code contributions in software projects. I've since gone to co-found and be the CTO of Miracle, a growing tech startup focused on extracting insights from codebase and software development processes. I'm also the creator of Apache DevLake, which is the dev data platform currently being incubated by the Apache Software Foundation. That is the tool we'll be using today that will enable you to implement DORA metrics in just a few minutes. So you probably have seen a lot of conversation and chatter around DORA metrics. And my hope today is to really focus on the practical parts of this from the perspective of being the CTO of a growing company, but to also bring that with some of the precision that's necessary to really understand this with some of my academic background. Without further ado, let's dive in. So for decades, how to measure software development performance has been a challenge for software developers. People have used metrics including lines of code, man-hours, function points, and later velocity in the form of story points. However, none of them really worked. These metrics are easy to game and oftentimes incentivize the wrong behaviors when they're treated as the goal. Martin Fowler even wrote an article stating that software productivity cannot be measured back in 2003. But ultimately, as you guys all probably know, if you can't measure it, you're not going to be able to improve it. And truly what gets measured gets managed. So how does DORA take on this challenge? For those of you that aren't familiar with DORA, DORA is a well-publicized framework that provides a clear approach to understand the effectiveness of a software delivery process. What's smart about DORA is that they don't attempt to measure productivity directly. Instead, they're focused on measuring the velocity and stability of the software delivery process. When these two distinct focus areas are considered as a whole and not independently of one another, the framework becomes much more robust and harder to misinterpret. At the heart of DORA are four key metrics divided into two groups, velocity and stability. Velocity is measured by deployment frequency and lead time for changes. Deployment frequency is the number of successful deployments to production. It shows how frequently and rapidly are your team releasing to end users. Lead time for changes is measured by how long does it take from commit to code running in production. Lead time for changes is very important for your team because it reflects how quickly your team can respond to user requirements. For example, let's say your user reports a bug. How quickly can your team create a fix and roll that fix to production is critical to user experience. So velocity is one side of the equation that describes the tempo of your team. But equally importantly, DORA is emphasizing stability, which is how robust and stable is the software that's being released, if it's being released quickly. Stability is measured by change failure rate and mean time to recover. That is the percentage of deployments causing a failure and how long does it take your team to recover from a failure once it finds one. The DORA framework then categorizes teams into groups based on their scores on these metrics, ranging from low performers to elite. You can get a quick assessment of where you stand on DORA metrics using the benchmark shown here or from the report. So none of these metrics are super exotic or complicated, so you might be asking, why are we even spending time talking about this? Well, there are a few really important challenges. The first of which is that much of this data is scattered. It's in many different tools and in many different formats. So unless you're dedicated to spending hours and hours extracting data from the DevOps tools you use, or living in spreadsheets manually entering information to get everything where you want it to, with DevLake solve this problem by making all of that data something you can query in one place. So that's problem number one. Problem number two, of course, is that no two teams, no two projects, no two companies are the same. They all have their unique processes. For example, when it comes to deployments, one team might have one pipeline for each environment they have, where another team might have one parameterized pipeline that deploys to all of their environments. So in terms of establishing something that can be a one-size-fits-all solution, the real case is one-size-fits-nobody. So we wanted to make something that get it in your hands today, that regardless of what tools you are using, what your specific process looks like, you're going to be able to bring the necessary data together and actually compute all of these DORA metrics. So that you can remain oriented with the tool that we are going to be using today, I thought it might be helpful to give you a brief introduction of how DevLake works and what are its key components. So the best way to understand DevLake on a high level is that it's a solution that gives you the capability to ingest, analyze, and visualize all of your dev data from many different tools, all in one customizable place. The user flow is simple. You first install DevLake via one of the many options we provide, including Docker Compose, Kubernetes, or an easy-to-use Helm chart. The next step is to collect data from your DevOps tools by creating a pipeline within DevLake using either DevLake's frontend or its API. Once data has been collected, it's time to explore and examine your data and metrics with DevLake's pre-built Grafana dashboards. These dashboards cover various use cases, including DORA. And if you ever run into a unique use case, you can always extend DevLake and make your own custom metrics and dashboards. DevLake provides detailed documentation on its data schema to make creating new queries simple. So DevLake is composed of a few key components. First, we've got Config.UI, which is simply a neat frontend where you can properly configure and connect all of your DevOps tools. Make sure you can run the pipelines to get the data you need. The API server is DevLake's core service, and the runners do most of the heavy lifting. DevLake has a whole ecosystem of plugins to work with different tools, and if you ever miss something, you can dive right into our community. People are building new things, and we've made some relatively straightforward documentation for you to readily implement plugins of your own. The database stores all the data collected from the DevOps tools, as well as DevLake's metadata. You can choose what database you want to use based on your own infrastructure and preference. Lastly, data visualization is done via Grafana. So now you have a good understanding of what exactly DORA metrics are and how DevLake works. Let's talk about how DevLake computes DORA metrics and what configurations are required from the users. There are three key underlying entities for computing DORA metrics. They are changes, deployments, and incidents. Changes entity are just pull requests for most teams and usually do not require any additional configuration. It's needed for calculating the lead time for changes metric of DORA. DevLake can pull changes from your code hosting systems like GitHub, GitLab, and Bitbucket. Deployment entity is needed for almost all DORA metrics and usually comes from your CI/CD tools. DevLake allows users to select specific pipelines from Jenkins, GitHub Actions, and GitLab CI as deployments. For maximum flexibility and accuracy, DevLake also provides a custom webhook for users to push deployments entity to DevLake. If your CI/CD tool is not yet supported by DevLake or you use a parameterized build, then webhook is the way to go. Lastly, incidence entity is needed for the stability-related metrics in DORA, including change failure rate and mean time to recover. Similar to deployments, users can select issues with certain labels as incidents, or use DevLake's webhook to push incidence entity to DevLake. We are also working on integrating with more incidence management systems like PagerDuty and Sentry, so stay tuned. Now, if you have gone through the process successfully, which hopefully shouldn't be too difficult, you should get something that looks a lot like this from DevLake's pre-built Grafana dashboard. For each of the 4 metrics we have talked about, this dashboard has one panel dedicated to visualizing its trend over time on a monthly basis. We have number of deployments per month, lead time for changes per month, change failure rate per month, and mean time to recover per month. These trend panels enables users to track their improvement over time. And we are also providing you with benchmarks to be able to determine whether you're at the levels that DORA is considering best practices. Hopefully you're exceeding them, which I imagine many of you are, and importantly, it also shows you where maybe you are below those thresholds, giving you some more objective direction for improvement. Thanks for your time today. Hopefully, through today's presentation, you feel much better equipped to go and implement DORA for yourselves. We invite you to jump in and take a much closer look at DevLake. If you go to devlake.apache.org, you'll find everything you need to use this open source project. And join our vibrant community of well over 100 developers, all of whom are active, helping each other extract more insights from their software delivery process. I look forward to connecting with all of you, and thanks again.